Today I'm going to talk about CSS and JS. So here is the plan. React and CSS, what are inline styles? Problems solved by inline styles. Interesting CSS and JS libraries. What is actually JSS? Problems JSS solves. And of course, unsolved problems. So why I'm talking about CSS at the React conference actually? The problem is that React has this good part in it, and this is component-based model. We create components, and we build our application out of them. But inside of these components, most of the time we use regular CSS, which has been designed for documents, not for components. Like it has been designed in 1996 or something, and we are still using it, and we leave the problems it brings. So this is not a good fit, and we have lots of ways to do it, to solve it, and I'm going to talk about them and about one I'm trying to use. First JSS release happened actually in October. Oh, my slides. So yes, the first release has been in October 2014. And I also did a presentation on Berlin.js about it, but I didn't receive any feedback, any excitements, anything, because just people didn't want to believe that CSS has actually real problems. But I mean, they knew it, but they tried to ignore it. 1 month later, a guy called Christopher Pseudo, he did a presentation at Nation.js just 1 month later, and talked about the same issues. He pointed very good issues about it, and he kicked off like lots of discussions about it. I mean, Christopher is working on the Facebook's he's from Facebook's infrastructure team, so this is probably the point why everybody started to think about it, like, oh yes, maybe we have problems. And this is the famous slide from his talk. He pointed to like seven things, and this is global namespace, dependencies, dead code elimination, minification, sharing constants, non-deterministic resolution, and isolation. To explain actually benefits from my solution, I need to start with these slides, because this is kind of the base of the like initial problems we have been always trying to solve. So his suggestion is to use inline styles to solve these problems. But first of all, what do we? Oh, this is excitement. Do you guys also feel this, like adrenaline, when you present? All right. So what do we call actually inline styles? Traditionally, in HTML, inline styles is actually a string, which is a style attribute. In React, it's something different. In React, it's an object. You can see it here. In React on the left, it's an object. And when React renders elements, it is applied to the style object directly. So every property from this object is going to be applied to the DOM. And here's the biggest issue from the CSS is the global namespace. To understand it, actually, you need to imagine to write an entire application inside of just one single function with just one scope. And you can imagine that this is going to to be hard to maintain. But not all CSS is bad. It's selectors. Selectors are evil, and they are designed for documents. Next problem, it results basically from the global namespace. It's implicit dependencies. Basically, when you write your components or HTML, you expect every CSS rule is already in the page. And once you expect it, you don't really know which CSS rule is used in which component, because it can be anywhere. And you cannot change it because you don't know what is going to be broken. A nice thing when using inline styles is we get dead code eliminations for free, because, for example, Clojure compiler is very smart and it will remove everything from your code what is not in use. It also allows us to rely on JavaScript minification. Clojure compiler is, again, just smart as hell. It will compile this code into the one on the right. And we also have no selectors, which is a big part of CSS, and we don't have them. Another use case is sharing constants. I tried to find some practical use cases for sharing constants between JavaScript and CSS. There are some. For example, data-driven styling, which means once a user can influence the representation of, like, for example, to choose a theme or something, you need to apply his change to the entire style sheets. Basically, you would need to render at runtime your style sheets. Sometimes you want to share breakpoints. In media queries, you have breakpoints, and sometimes you want to change something in your representation from the rendering perspective once one breakpoint is reached. And one great use case is actually JavaScript layouts, which is like a big topic, but it's not really in use nowadays. By non-deterministic resolution, I was reading this twice or 3 times, but basically this is about this CSS specificity concept. CSS specificity is the logic which defines how rules are going to be merged once they apply to the same element. And there is a bunch of rules. Here is a quick quiz for you. I have just one button. On the left, you see one style sheet with color blue, and on down there, you have another style sheet with button with color red. And on the right, you see the HTML. So here's a quiz. Which color does this button actually has after it's rendered? What do you think? Red? I think it's red. No, it's actually blue. But nobody raised yes, no, it's not red. It's actually blue. But try to wrap your head around this. Once you have not just the one button, but the entire application written in this style. Next problem inline styles solve is isolation. As they have no selectors, they cannot break external components, so they are isolated by default. And also they have another feature is a very high specificity, which means aggressive selectors cannot break your styles just by accident. Also, complex selectors and nested selectors is actually hard to reason about and hard to maintain. And they can really slow down your application in general. CSS makes us write code in a very redundant way. It's like we write all the time the same things. You could say you use like preprocessors like Stylus or Sass, but it doesn't matter. What you generate is CSS, and this is going to be redundant, and it increases your CSS payload total. So the question is, can we do better than inline styles? And I think yes. And there is a number of alternative solutions. libraries which use different techniques, and there are people who are trying to compare them to make it easier to choose one of them, but it's still very hard. And there are lots of alternatives. What I'm going to do is I will divide these alternatives into 3 basic categories based on their rendering behavior. It's pure inline. It's what React has built in. It's mixed mode and pure style sheets. So pure inline styles is already in React, but it has its problems. It has no support for media queries, for keyframes, for pseudo selectors, for lots of things. And it has performance downsides I will talk about later. Mixed mode is, for example, Radium. It uses React events to simulate pseudo selectors. It uses style sheets for media and others, and it uses inline style for everything else. It's kind of nice library, but it uses lots of complicated techniques. It's not obvious how to debug it when once you got a problem. It's a bunch of complicated code to make it run. And there is a third category is pure inline sheets, where I would like to highlight 2 libraries. One is Aphrodite, and the second one I'm actually going to talk about is GSS. Aphrodite is created by Khan Academy and has some interesting ideas about rendering. So when I'm asked to define what is actually GSS, it's hard to do. So I wrote some statements which basically describe GSS more or less accurately. And this is good parts of CSS only. It's designed with components in mind. It's declarative JavaScript. It's JavaScript to CSS compiler. And the most thing I'm happy about is it's easy to reason about. How does it work inside? First, once you pass your styles to GSS, it's creating virtual CSS tree, similar to virtual DOM something. It's basically an abstraction for your rules. Then it calls plugins on every rule, and then it outputs regular style string, CSS string, and renders it inside of a style element into the DOM. I mean, this is very straightforward. Also, there is a React.js integration, which is optional. JSS is basically usable without React. It's framework agnostic. But if you use React.js, you get some additional optimizations. It's lazy compilation, which means before a component did mount, nothing is going to happen with your styles. They are not generated. There is no overhead at all. Once they are mounted, it's rendered just once and cached forever. And doesn't matter if you mount or unmount, there is nothing, no overhead anymore. It's just using the style sheet. It has generated once. And by doing ref counting, it knows when a component needs a style sheet, and it just inserts the style elements into the head or removes it. A really simple example with React, just a button. You can see there is no magic. It looks almost the same like inline styles. In this example, I'm just using decorator. You don't need to use it. And here is a bit more complicated example from a real application. On the left, you can see a button. You can see the generated HTML. It's again nothing exciting. It's really simple. It has a class inside, which is generated. It's conflict-free. And on the right, you see styles view where you see regular styles you get. But when once you see the style link there, once you click there, you are not going to be impressed. There is again just boring CSS output. This is the style, which is in the head. And you see your style sheets rendered as usually. It's exactly the same workflow you have with traditional CSS, just with some enhancements like generated class name. So, which problems does it actually solve? It solves all issues inline styles solve. It solves all issues introduced by inline styles. And it solves more CSS issues. And here's the new plan. I don't want to read it. We will go through every point. For example, this is the syntax for media queries. On the left, you see JSS syntax in ES5 for media queries. This is pretty much the same you would write in CSS, just in JSON. On the bottom, you see the generated CSS out of it. And on the right, I'm using ES6, and I'm using string templates inside the property name. And this is a valid ES6 syntax to have a variable inside of it. So basically, I have a constant breakpoint, which I can share with JavaScript and use it for example, changing representation or rendering something else when a certain breakpoint is reached. Pretty much the same is for Keyframes Animation. We get them also for free, just because we're using a regular CSS, and it's very much the same what you write in CSS, just in JSON. And on the right side, you get JSS and ES6, which uses a constant for identifier, and the constant is generated. It's any function you want to use for random string generation. Because actually, keyframes identifiers are also global. Once you write your name there, it's global for the entire document, and it can and will conflict at some point. Font phrases, pretty much the same, very straightforward. Pseudo selectors. The syntax I use here is actually inspired by Sass. It's more or less exactly the same. And you see this end character, and you can, after that, you can use any selector you want. It's not just hover and active or before, like things supported by a radium. It's anything you want to use. It's just what CSS can do. And also you can use as like the last thing on the left, at end and span. This is basically a selector which uses global selectors, but it's scoped to the current model. So if you really need to use it, but with caution, because at some point it will break your isolation. You are accessing basically any component inside of your current component. And there is possibility for fallbacks. In CSS, you can write the same property name multiple times. You can do this in JSON, but we can use arrays. So on the left, you can see how you write fallbacks with JSS. And this is actually straightforward. We got rules caching for free. Basically, it's, again, pure CSS. CSS generates a rule just once, and it can be used during the entire application lifecycle on any nodes. You cannot do this with inline styles. You need to apply inline styles to every node every time it renders. You got also rules sharing for free, and which means that if you have a list with hundreds of items in it, you need to apply styles to every item. Once you use inline styles, you need to do it for every item. Once you use normal CSS or JSS, which is the same, you generate just one rule, and after that, it's applied to all elements. And this might be a huge performance benefit. And yes, class names are fast. They are faster than inline styles always. because, for example, this is the rendering pipeline for inline styles in React. This is what React needs to do to apply inline styles. It looks for modified properties. It looks for properties which need to be unset. It needs to ensure property name value is valid. It needs to ensure default unit. And then it needs to apply all these properties to every element. And like React does it for every rendering. Yes, and everything results in a much smaller payload. In my calculations, up to 50% smaller styling payload once you use all these techniques, because you can cut selectors, you can cut vendor prefixing because it happens at runtime. You can reuse your declarations much more efficient. And yes, JSS is tools agnostic, which means you can use it with React or with any other framework, as well as it is infrastructure agnostic because you don't need special build tools like because it's just pure JavaScript. You can use whatever you use for your project to build your JavaScripts, Browserify, Webpack, you name it. And it's extensible. It has very small core. It's less than 4 kilobytes, minified and compressed. And it is extensible because it has a plugins API. One of examples for a plugin is vendor prefixer. Vendor prefixing is done at runtime, and it's done very efficiently. There is really very low overhead on it. Another great example is inheritance. We have still no true isolation. Just because we use conflict-free class names, it doesn't mean we have true isolation, because CSS has inheritance. We inherit some rules from the parent elements, and here you go. We got a contributor which has created a JSS plugin who solved inheritance. This plugin protects styles from inheritance and automatically creates a reset rule and applies it to every user's rule. Inheritance problem solved. And yes, we got unsolved problems. Some of you might feel it's an overengineered solution. If you feel it, don't use it. Some developers work on small projects. The entire CSS code base might be like so small that it fits into your head, and you are not going to get some problems. So you don't need any CSS solution at all. Some of them say it's a wrong language. Well, might be true. You are free to experiment. For example, there is no real code behind it. You could try to implement something like this. It's totally possible. In this example, I'm using text template redirects. As I'm running out of time, just Google for it later. And there is no standard DSL. If you use inline styles with a certain library, you need to use the same library as all the other projects. And we are missing dev tools. There is no autocomplete tools. There is no CSS-specific highlighting. There is no linters. And it might block initial rendering. You should use this. I mean, there are workarounds for it. You can use it where it doesn't matter, where when in your application the entire rendering happens in React, you cannot, I mean, if nothing will happen until your React is loaded and or the component is loaded, it doesn't matter at all. You can use pure server-side rendering, and also you can go for a hybrid approach to render initial view server-side and then start your React and JSS at runtime. If you remember just a few things from this talk, I would say CSS in JS is not only for big projects like with problems at scale like Facebook has. It's for any maintainable project. I use it in a very small team, and every time I look for legacy stylus code, I'm really happy to not to be forced to use it anymore. You can use inline styles. They are still good for some cases. For example, state styles. It's when your viz depends on its state. Also for animations. And the most important thing, don't be religious. Keep an open mind and use tools which solve your problems.